السلام عليكم ورحمة الله وبركاته. بسم الله الرحمن الرحيم. Last time we started to talk about probabilistic reasoning, and actually we started the revision of probability that we said that we needed before we go through probabilistic reasoning, so that we make sure that you remember the things that you went through in earlier courses about probability and statistics. Actually, probability in this case. Quickly summary of what we covered last time. We said that a random variable is something in the world that we are not sure of, or we have some uncertainty about, like whether the temperature is hot or cold, and whether it is raining or not, or where is the ghost in the game that we saw last time, and so on. So anything that we are not sure of, we have uncertainty about, can be modeled by what we call a random variable. We also talked about probability distribution, and this is a table in which we list all the values of the variable, and for each possible value we associate it with a probability. So it's called a distribution because we distribute the probability over all of these values, and of course the sum of them is 1. So that's what we meant by probability distribution. And we also mentioned what we call joint distribution. So the joint distribution is actually also a probability distribution, but it is over a set of random variables instead of just one. So in this case, every row will be one outcome or one assignment of values, or one combination of values for these random variables. Okay, and for each of these outcomes, we will again have the probability of the joint assignment of these values. And of course, since this is a probability distribution, the sum of all of these values, the sum of all of these probabilities will be 1. Okay, so here, for example, we have the joint distribution of the temperature and the weather. So you will see that since we have 2 values for each there, then we have 4 rows. Each row is called an outcome. Let me change this. Each row here is called an outcome, okay, because it's a combination of values for both variables, and this is the probability, or actually this is the joint probability of having T to be cold, T to be hot, and the weather to be sunny. Okay, so that's the joint distribution. And the last point that we covered last time is that we said that the joint distribution, when we have so many variables, the table of the joint distribution will be huge, and it will be impractical to either compute it or to keep it in memory or process it in that size. So we'll have to find ways to shrink this huge table, because it has an exponential dimension, exponential size, as we mentioned last time. It will be very important to shrink it down to smaller tables so that we can do our reasoning over in an efficient way, of course. And that's exactly where we stopped, I think, last time. Let's today start by talking about probabilistic models. Okay, so probabilistic model is just a joint distribution over a set of random variables. Okay, so when we have a joint distribution over random variables, we call this a probabilistic model, because it models the interaction between these variables. In fact, it models the probabilities of the interaction between these variables. That's why we call it a probabilistic model. Okay, so again, it is just the joint distribution table. Just the joint distribution table is also called a probabilistic model. Again, the joint distribution table has the variables. Each variable has a domain, and each row is called an outcome, and the sum of the probabilities, of course, is 1. And these variables in a probabilistic model, not all the variables have to be interactive, or have to be dependent, or have to be related. Okay, some of them might not be related. And that's what we will inshallah discuss later after we are done with this revision inshallah, starting next week. So that's what we mean by probabilistic model. Now, what is an event? An event is a set or a list of outcomes. Okay, a list or a set of outcomes. So the probability of an event is the sum of the probabilities of the outcomes. So if we have an event, okay, that has multiple outcomes, then to get the probability of the event, we just sum the rows that are corresponding to the outcomes. Okay, so for a joint distribution, we can calculate any probability, or we can calculate the probability of any event. If we are given the joint distribution table, we can calculate the probability of any event from that table. Any event. For example, let's say that we have this joint distribution. Okay, we have two random variables here, the temperature and the weather. We want to calculate the probability that it is hot and sunny. So that's an event now. Where are the outcomes that correspond to that event? It's just one row, right? It's hot and sunny. So that's the row that corresponds to that event. So the probability here is just 0.4. It's just one outcome. Now, if we want to calculate the probability that it is hot, it's hot. So now that's another event. And that event now corresponds to multiple rows in the table. So where are the rows in the table that correspond to that event? These are all the rows in which the temperature is hot. So this row, the temperature is hot, and that row, the temperature is also hot. Now, what is the probability now it's hot? It's the sum of these values. Why is that? Because we have this, right? The probability of an event is the sum of the probabilities of the outcomes that correspond to that event. So the probability that it's hot, it covers two cases, when the weather is sun and when the weather is rain. So this probability is 0.5. Now, if the event it's hot or sunny, then we have this row because it's hot here, we have this row because it's hot here, and we also have this row because it's sun here. Okay, so we have these three rows now. This row doesn't count because it doesn't correspond to that event. It's neither hot nor sunny. So that row is out. Now we have these three rows correspond to this event. So the probability will be the sum over these values, which will be 0.7. Okay, so that's how we calculate the probabilities of the events. And that shows also that we can calculate the probability of any event, given that we know the joint distribution. So from the joint distribution, we can calculate any probability or probability of any event. Notice here that this is a joint probability. Okay, so we have to have the joint distribution in order to calculate the probability of any event. Typically, or usually, we care more, or we are interested more in the events that have partial assignments. What do you mean by partial assignments? Events that correspond to specific variables, not all of them. For example, like when the temperature is hot. We didn't say anything about the weather here, right? So that's typically what the kind of probabilities that we will be interested in, which means that it will correspond to multiple rows, not just one row in the table, because there are some events, some variables that we don't care about. We care just for a specific set of variables. So usually this is the kind of events that we are looking for. But again, we still can calculate the probability of any event, given that we have the joint distribution table. Here is a quick quiz. Let's say that we have this joint distribution. We want to calculate these probabilities. So anyone? Any volunteer? Saad? I didn't hear your voice for a very long time, Saad. Wa alaikum assalam wa rahmatullahi wa barakatuh. Where are you? You have been busy. Okay. So sorry for bothering you and wasting your time, Saad. Okay, good. No, I'm just kidding. Okay, I know that everyone is busy now at that time. We are very close to the end of the semester, and you are a senior student, right? So you have a senior project. Okay, okay. Good luck, inshallah. Okay, so what are these probabilities then, Saad? Tell me how you got it. So plus x and plus y. So that's the joint probability, right? So how can we get it? Yes. So yes, yes. So we always look at the rows that correspond or that match the conditions that we have. Okay. So here we have plus x and plus y. So that's the only row that matches the event. So that will be 0.2. How about plus x, Sam? Yes. First row and second row. Yes. So 0.2 plus 0.3, which is 0.5. So that one was 0.2. That one was 0.5. How about this one? Yeah, so first row, second row, and the fourth row. Yeah, and that's because we have minus y here. So the probability will be, yeah, because we have 0.2, 0.3, 0.1, we add them up together, that will be 0.6. Thanks, Saad. Okay, any question about this? Okay, now let's switch to what we call marginal distribution. Okay, so a marginal distribution, it's still a probability distribution, by the way, and it is just a subtable from the joint distribution that we will get by eliminating some variables. What do you mean by eliminating some variables? If I have this joint distribution, that's probability of t and w, and I want to get only p of t. So that's a joint distribution. That's a probability distribution now because we have just one variable. So if I told you I want to get the probability distribution of t, that means that I will have a table in which I have the value of t, which is hot and cold, and for each of these values, I will have a probability, right? So that's the probability. So I will have a probability here and I have a probability here. So that's the table that I want for a probability of t, right? Now look at this table. This is just a subtable of this by eliminating the variable w. But it's not just getting rid of this column. When we get rid of this column, we add up the rows that are similar. Okay, so to calculate the probability of hot, we look at the rows here that have hot and we add the values together. So the value here will be 0.5. Ignoring completely the values of w. Ignoring the values of w means that we sum over the different values of w, which we call marginalization. So we eliminated w completely. Okay? We eliminated w. We call that marginalization. We do it by looking at the rows that have the same values of the variables that we want to keep and sum up the corresponding probabilities. So for cold, we will sum up these two values, so we will get also 0.5. So that's now what we call the marginal distribution. It is actually a probability distribution, but it is now called a marginal distribution because we got it from the joint distribution by marginalizing w. okay, by marginalizing W. Why we call it marginalizing W? Because usually when we have a table like that, if you look at this figure at the top right corner, this image, you will see that sometimes we do some of the calculations at the margins. When we add the columns or add the rows, we call this we put some numbers on the margins. That's why we call it marginalization here. And here, exactly, marginalization also means that we eliminate one of the variables, at least one. We might eliminate more, by the way, but usually we do one by one. Okay? So here is the equation for it. So if we have a variable t, we want to get the probability for, we sum over the other variable s. So here, s here is w in our case. So we sum over all possible value of w. So let me make it w to be consistent with the example. So to get the probability of a specific value t, notice that this is a small letter here, which means that this is a specific value, and that as a whole will give us one number, which is the probability of t equals that value, will be the sum over all possible values of w of the joint probability of t and w. Okay, so fixing t here means that we want to get, that's because we want to get the probability of t here, and summing over w because we want to get rid of w, we want to eliminate w, or we want to marginalize w. Okay, if I want to get p of w now, I will get similar process. So let me erase everything now, and sorry, let's get p of w. So p of w again will be a table that will have two values of w here, sun and rain, and that's the probability of each. Now what is the probability of sun? Look at the rows of sun, this one and this one, so that will be 0.6, and the probability for rain is this one and this one, which is 0.4. So now we marginalized out t. In fact, we sum all the rows that match the specific value here over all possible values of t, okay, to get the marginal probability. So we summed over t. Whenever we sum over all possible values of a specific variable, it's gone. It's marginalized out. It's eliminated from the resulting table, or in the resulting table. Okay? Because we sum over all the possible values of this, khalas, that's gone, and we just keep the other variables. And this is the general rule. If we have two variables, x1 and x2, and I want to just get the marginal distribution of x1, I will sum over all possible values of x2, given that here I want to compute just one probability of x1 equals x1 capital equals x1 small, that's the value. So I will sum over x2 for all the joint probabilities of x1 equals x1 small and x2 equals x2 small. Okay, so we fix x1 here and we change x2. Changing x2 over all possible values, that's marginalization. Let's do a quick quiz. Given this joint distribution, I want to get p of x. Anyone? So that's the marginal distribution now, because I want to eliminate y, right? Someone else other than Saad. Yusuf? Wa alaikum assalam wa rahmatullahi wa barakatuh. It will be 1. What do you mean by it will be 1? Yeah, so first, the marginal distribution here will be a table, right? Okay, so how many rows in that table? How many rows in that table? 2 rows. Okay, so we have the value of x here and the probability, and then we have 2 rows. What are the 2 values of x? Plus x and minus x. Okay, now what are the probabilities? Okay, tell me how. So plus x here, Yusuf. Yes, so that's 0.5 and 0.1 and plus 1 and 0.4 and 0.1 is 0.5. Okay, so now we eliminated y. Type. Okay, now how about a probability of y, Yusuf? No, just a second. So plus y, how can I get this probability? Okay, so you sum over x now. You fix y and sum over x. Yes, so we'll have for plus y, we have 0.2 and 0.4, so that will be 0.6. And for minus y, yes, so that will be 0.4. And as you indicated, these have to sum to 1, of course, because still this is a probability distribution. So we marginalized out x and we got the probability distribution of y. Similarly here. Thanks, Yusuf. Any question about this? So that's how we calculate marginal distributions. Now switching to conditional probabilities. What do we mean by conditional probability first? Conditional probability means that we have known some evidence, we call it evidence. We know the specific value for a variable called evidence, and we want to calculate the value, we want to calculate the probability of another variable being assigned a specific value given what we know already. So we know B, and we want to calculate the probability of A given B. Using Venn diagrams, if the red area here is the probability of B, and the blue area here is the probability of A, then the probability of A given B is the area out of probability of B in which A also happens. So that area. So the percentage of the area of B in which A also happens. So given that we know we are in A, given that we know that A happened, what is the probability that A also will happen? The rule says that probability of A given B is equal to the joint probability of both, which is indicated by the intersection here, that area. Let me change the color, so it will be that area, divided by the area of the evidence, which is this area, which is the red area. Okay, so the conditional probability P, the probability of A given B, is the joint probability of both events divided by the evidence, divided by the probability of the evidence, which is probability of B in this case. This is one of the very important rules in probabilities, the conditional probability. So we are given an evidence and we want to get the probability of another event, given that we know the evidence or we know what we observed already. Okay? So here's an example. Given that we know the joint distribution, again, as I told you, given the joint distribution, we can calculate any probability, even if it's conditional. So we are given this joint distribution. Now I want to calculate the probability that the weather is sun, given that the temperature is cold. So using the rule, this is equal to the joint probability of both, which is whether, let me write it in short form. So probability of S and C, that's the joint probability of S and C, divided by the probability of the evidence, which is C. Now, what is the probability of S and C? That's the joint probability, right? So we can look it up from the table directly. It will be just one row here. So sun and cold, this is the row corresponding to that joint event. So that will be 0.2 divided by the probability of C, which is the probability of cold. Where is cold here? In this row and in that row. So the event here, which is the evidence, corresponds to two rows. So the probability of C here is 0.2 plus 0.3. Okay, so 0.2 over 0.5, which is 0.4. So that's the conditional probability of sun given that the temperature is cold. Okay. So this is how it's calculated, and that's the denominator. Okay, now let's get a quick quiz. Given this joint distribution table, I want to calculate these probabilities. Any volunteer? Anyone else other than Saad and Yusuf? Should I call names here? Maheen, are you with us? Maheen? Said? Said? Mubarak? Okay, Hamza, did you raise your hand? Hamza? I saw a hand and then no response. Okay, seems like we have a long list, but actually we don't. Okay. Okay, Saad? Just to save my life. Yes, so that's the evidence, right? The evidence is plus y. Yes, so what is that probability? Yes, yes. Divided by probability of positive y. Very good. What is the numerator here? So plus x plus y is 0.2, that's 1 row. And the denominator? So plus y is here and plus y is here also. So 0.2 plus 0.4, that's 0.6. I want to write it that way for a reason that I will tell you later. So that's 0.2 plus divided by 0.6, which is 1 over 3. Yeah. Okay. Hamza, I think you raised hands again, so I hope that the mic is working now. نعم أسمعك بوضوح. You mean the probability, right? Probability minus x and minus x and plus y divided by probability of plus y Yes. Okay, which is which row is that? Minus x and plus y, so that's 0.4. That's 0.4 divided by, divided by 0.2 plus 0.4. So this is 0.4 over 0.6, which is 2 divided by 3. Okay, notice here that the sum of these two, thanks Hamza, notice that the sum of these two here is 1, okay, and that's because we have the same evidence and we have all possible values of x, plus x and minus y, plus x and minus x, okay, and we'll call that conditional distribution, I think, in the next slide. I will leave that to you. Any questions on the conditional probabilities? Okay, so we'll switch to conditional distribution now. Conditional distribution. So when I tell you I want to compute P of hot given rain. So this is not a distribution, right? This is just one outcome. This is a number here. It should be a number. Okay, so that's just one probability. But if I told you I want to compute, so that's a conditional probability. If I told you that I want to compute P of T capital given rain. So that's now a distribution. And we need in that distribution, which means that we will have a table. And in that table, we'll have all possible values of T given that the weather is rain. Okay? Given that the weather is rain. So, for example, if I want to compute probability of W given T equals hot, we call this conditional distribution because we have a condition here, but we have all possible values of the random variable. So that's conditional distribution. Now, how can we calculate this conditional distribution? The same way we calculated every probability. We just need to make sure that what values we should have in for the variables. Okay, so here we have W. T is fixed, W is not fixed, so we'll have all possible values of W, which is sun and rain. Now these probabilities are what? This probability is the probability of sun given hot. And that probability is the probability of rain given hot. So this is by itself is a conditional probability. This is conditional probability. This table as a whole, we call it conditional distribution because it's a distribution over all values now. Okay. Now, how did we calculate, or how can we calculate these probabilities? The same way we calculated them in the previous two slides. So, for example, probability of sun given hot is probability of sun and hot, which is sun and hot here is 0.4, so that's 0.4, divided by probability of hot, which is 0.4 plus 0.1, so that's 0.4 plus 0.1, which is 0.4 divided by 0.5, which is 0.8. Right. How about probability of rain given hot? Again, it will be the joint probability, rain and hot. Where is rain and hot here? This is 0.1. That's 0.1. Divided by the probability of hot, which we already calculated here, which is 0.4 plus 0.1, which is 0.2. Notice now so many things from what we just did. First thing, the sum of these values is 1. And that's expected because that's a probability distribution. It is called conditional distribution, but it is a probability distribution. So the sum of these values have to be 1. Notice something else also, that the denominators, the values of the denominator in both cases is the same. 0.1 plus 0.1, 0.4 plus 0.1 here, 0.4 plus 0.1 here. Why is that? Because we always divide by the probability of the evidence, which is the same in both cases. Okay? Notice something even further, which is that this value 0.4 is plus 0.1 is actually the sum of these two values. Okay? And that's because, given the evidence, we want to get the probability that sun given hot and rain given hot, so that's within these two rows already. Okay, so the sum of all of these rows is the denominator, and the values of the numerators are actually the values in each row. Okay, keep that in mind. We will use this, I think, in the next in 2 slides from now, I think. But for now, this is how we calculate the conditional distribution. Same thing, we calculate probability of W given T equals cold. The only difference is that we'll now focus more on these two rows. Okay, so we calculate the probability of sun given cold, which is 0.2, divided by the sum of these two, which is probability of cold. So 0.2 divided by 0.5 will give us 0.4. Similarly here, probability of rain given cold is the joint probability of rain and cold, which is this probability, divided by the sum of these two probabilities. So 0.3 divided by 0.5, which is 0.6. Okay, so this is called conditional distribution. This is called conditional distribution. Sometimes we stitch these two tables together in one bigger table. Now, this whole table is not a distribution, it's actually a concatenation of multiple probability distribution tables. And in that case, we add just a column for the temperature here, just to indicate what is the evidence for each case. Okay? Okay, now we saw how we calculate the conditional distributions using the rule of the conditional probability, right? Now let's see a shortcut of computing these probabilities, as I already indicated in the previous slide. We call this the normalization trick. What do we do in the normalization trick? We have a joint distribution, and from that joint distribution, I want to calculate a conditional distribution. Probability of W given T equals a specific value. Using the rule, we did it that way, right? We used the rule, the conditional probability rule, and we calculated that way. We found out that this is 0.4, and we found out the other one is 0.6. That's what we did in the previous slide. Okay, using the conditional probability rule. And as I said, we noticed that these two values are the values in these two rows, and the value of the denominator is the sum of these two values. So the normalization trick will include these two steps. The first step is to select the joint probabilities that match the evidence. Where is the evidence here? Remember that we want to calculate, from the previous slide, we want to calculate the probability of W given T equals C. So that's the evidence. Okay, so first we select the joint probabilities from the joint distribution that match the evidence. Where are the rows here that match the evidence? The evidence is that T equal cold, right? So we select these two rows only, and we just eliminate these two rows. That's the first step, step 1. So out of this step, we will have T, P, we have, okay, just a second. T, W, P, we have cold, We have sun, 0.2, cold, rain, 0.3. Okay, so that's now the table after the first, after the first step. Okay, now the second step is, before we say the second step, these two values are actually the numerators. So this is 0.2, which is the numerator here, and this is 0.3, which is the numerator here. What remains is to divide by the denominator, which is the sum of these two values. So we divide by 0.5, which is 0.2 plus 0.3. So the second step, we call it normalization. We call the second step normalization. Okay, so just everything. So that's the second step. That's the first step. We call it normalization. In normalization, we divide every entry by the sum of all entries. So we divide 0.2 by 0.2 plus 0.3, and we divide 0.3 by 0.2 by 0.3. When we do that, we will make the new sum to be 1. That's why it's called normalization. Bring it back to be to sum to 1. So doing that, we will get 0.4 and 0.6. So we don't actually need to do all of these calculations. We know, of course, how we do these calculations, but it is much easier to do it in these two steps. First, we select the rows that match the evidence from the joint distribution table. So we select these two. We just eliminate these. Once we get that, we just normalize. And normalizing means make them to 1 by dividing, make them sum to 1 by dividing by the sum of these entries. Okay, we call this the normalization trick. The normalization trick. Remember, we do this normalization trick when we are given the joint distribution and we want to calculate the conditional distribution. When we have the condition, this condition means that we have an evidence. We match from the joint distribution the rows that match. We select, from the joint distribution the rows that match the evidence. Then we normalize. Normalizing always means that we want the sum to be 1 in our context here. So we get the sum and we divide each entry by that sum. Then we get the final values. And that's exactly what we did here, but we did it through the rule. Here, after knowing how to do it using the rule, these two steps are much easier and faster. And of course, you know now why, because the denominator is always the sum of the numerators. Let's see an example here. Quick quiz. I want to get, given the joint distribution here, I want to get this conditional distribution. How did I know that this is a conditional distribution? Because I have capital letter here. Okay, capital letter, as we said last time, always refer to a random variable. So that's not a value, that's all the possible values of that random variable. Okay? Now, since we are given a joint distribution and we want to get a conditional distribution, we can use the normalization trick. Anyone wants to do it with me? Anyone other than Saad, please. Okay, Mubarak. Wa alaykum assalam wa rahmatullahi wa barakatuh. You were not there when I called your name first? And I said your name and you didn't respond, so that's why. Okay, go ahead. Yes, so the first step is to select the rows. Yes, the second and the fourth, because Yes, so the evidence here is minus y, so we select this row and we select that row. These rows are eliminated, we don't want them. Okay, so that's the first step. Sorry. Okay, so that's the first step. Now we have these two rows. Let me write them quickly here. Okay, then so we get the sum first. So what is the sum of these values? Will be 0.4. Yeah, so here we'll just need to divide by this value. Right? So it will be 0.3 divided by 0.4, which is 0.75. And yes, which is 0.25. Right? And now this is the probability of x given minus y, and this is x, right? And this is y, and actually we don't need to, we can actually remove this because we know that this is minus y for all. So we'll have this final conditional distribution table. Thanks, Mubarak. Any question about this? Okay, good. Now, just a quick note about the verb to normalize. From the dictionary, it means to bring or restore to a normal condition. Okay, bring or restore something to a normal condition. Now, what is that normal condition here? The normal condition here is to return back the entries to sum to 1. After we select from the table, the values that we selected will not sum to 1. Okay, to sum to 1, this is the action of summing, bringing them back to sum to 1 is called normalization. So the procedure here to do just the second step of the normalization is to compute the sum over all entries. We call it Z. Sometimes, by the way, this is called Z normalization, and divide each entry by Z. That will bring them back to sum to 1, and that's of course a condition for being a probability distribution. So, for example, if after selection we got these two entries, we normalize them by dividing by the sum of the entries. So we divide by 0.5, will give us 0.4 and 0.6. Notice that the sum here is of course 1. Another example, if we have these counts, so these are not probabilities but just counts, and this is just an example of the action of normalization. So if we normalize them, if we want to normalize them, then we sum all of these entries and we divide each entry by that sum. If we do that, then we get these values. Now they sum to 1, so they can be seen as probability distribution now. Okay. Okay. Any question up to this point? Actually, I wish we could go to the next set of slides, but it seems like we are almost on time by the end of the lecture. So let me stop here and ask you if you have any questions so far in this lecture or in the second half of the previous lecture, in which we started to talk about the revision of the probabilities. Do you think that this is redundant? I know that you know already these things from other courses, but I thought that a quick revision over these important concepts, random variables, probability distributions, joint distributions, conditional distribution, marginalization, all of these concepts we will rely on for the rest of the lectures in this session. So I hope that this is a good refresh of your memory, and I hope that this is not so redundant that will make you bored. Anyway, there will be a quiz on Sunday, which is quiz number 5. It will cover the logical agent sessions, which are 6 and 7, plus what we covered in the probability revision up to today. Okay, so again, it will cover 6 and 7 and 8.A, which we just finished. Okay, inshallah, talk to you on Sunday. Assalamu alaikum wa rahmatullahi wa barakatuh.